Hi everyone, my name is Jan Zahalka, and today I'm presenting a paper entitled II-20, Intelligent and Pragmatic Analytic Categorization of Image Collections. Images are a very rich data resource. Just looking at this one image, we see that there's a lot going on. There's a cyclist in Amsterdam at a particular location. There's a certain artistic impression from the image, and other semantic information that jumps right at us just from looking at this one image. In the analytic context, however, we more often than not have a collection of images, which is much larger than one. For instance, here we have a data set of 1600 images, and the method of just looking at the thumbnails to gain insight into what's going on in the collection might not suffice for analytic purposes. That's why we need sophisticated tools. Fortunately, multimedia analytics is here to answer precisely this call. Multimedia analytics is a combination of visual analytics and multimedia analysis. The famous visual analytics diagram by Kai et al. Fully applies to multimedia analytics. You have your data, you visualize it to the user, and you load it into the model, which more often than not has an AI component because you need semantic analysis. The user interacts with the model and iteratively builds up insight. II-20 is a complete multimedia analytics system for analytic categorization of image collections. The contributions of II-20 are threefold. First, it's a completely new machine model. Second, we introduce a new visual metaphor for visualizing image collections, which we call Tetris, after the famous game. And third, we introduce the fast-forward semantic interaction. In analytic categorization, you add images to categories of relevance, which we call the buckets. The buckets are fully defined by you, the user. At any time during your analytic session, you may add, remove, update, redefine, split, and merge buckets to match your current insight and notion of relevance. II-20's state-of-the-art machine model learns to model your buckets on the fly, assisting you in finding images that are relevant to your buckets right now. With its bucket flexibility, analytic categorization is a suitable model task for tasks on the entire exploration search axis. II-20's image view is by default a grid with fairly standard behavior. We can resize it in the control panel, and we can enlarge images by right-clicking on them, which also provides space for any associated information and metadata. Now, let's say we're interested in birds and flowers. So we first redefine the bucket 1 and 2 birds, add the image to the bucket. Then we do the same for the flower, but we have to create a new bucket first. Then we discard a couple of images we don't find relevant at this time. And finally, we hit Show More to obtain relevant suggestions. II-20 provides new suggestions almost instantly. We see pretty good suggestions for both buckets, as well as a small number of random exploration candidates to foster exploration. We can hit Accept Suggestions to automatically label the images, and we can keep going. If you want to review a particular bucket, we can open up the bucket view. Here we can view the images in two modes. We can sort the images, and we can also transfer images between buckets. The model updates instantly after each transfer, which implements bucket redefinition, including splitting and merging on the fly. For a change of pace, or when we grow bored of the grid, we may opt to continue in the novel Tetris view. Tetris is a dynamic, one image at a time metaphor, which complements the static batch mode grid. Images descend to the bucket on the bottom and get assigned to the respective bucket when they hit the floor. Tetris is very tightly integrated with the model. You can already see that the model is able to pretty much play the game itself with minimal interaction required. Using hotkeys, we can pause the flow, adjust the descent speed, steer the images between the buckets, and show an image metadata overlay. Let's say we want to really focus on the birds now and rapidly expand that bucket. That's exactly what the fast-forward interaction is for. So let's say that we want 10 more birds right now, so we select birds, specify 10, and we are pretty much instantly taken to the bucket view with 10 new bird images already being fast forwarded to the buckets. We can review the suggestions. They are marked with the fast forward icon, and transfer off the mistaken ones. Now we can close the bucket view. To truly support analytic categorization and cover the exploration search axis, the II-20's model has three components. The first one is the randomized explorer, which covers the exploration side of the axis. The other two are more tailored towards search, the interactive classifier, and nearest neighbor search, which itself is operating in either of two modes: approximate nearest neighbors or k-nearest neighbors. The Modulus pipeline operates as follows, and the components innovated by II-20 are highlighted in blue. Feedback from the user interface is collected. In this case, the user seems to be interested in birds. Then we might want to prune the train images, train the classifier. Then maybe the model asks a couple of Oracle queries, which is verifying the images the model is least sure about. So is this a bird? Is this a bird? And then we move towards producing the suggestions, which is where the magic happens. Instead of receiving suggestions just from the interactive classifier or from the search, the user will receive suggestions from all three components in a certain proportion. This proportion is determined by the performance of the interactive classifier and the nearest neighbor search in the previous rounds. In other words, if the user has been receiving relevant search results, then the model will slide more towards search. And when the results become, or the suggestions become less and less relevant, there will be more and more suggestions from the randomized explorer, and the model will be more in an exploration state. Then maybe the user finds something relevant again, we slide back to search, and so forth and so forth. Thus, II-20's model is able to cover the exploration search axis and dynamically slide alongside it, which, to the best of our knowledge, has been missing in the state-of-the-art in multimedia analytics so far. We have conducted two types of experiments. The first was an automated evaluation that used artificial actors, essentially software agents that simulate user behavior interacting with II-20 in a user's place, to answer whether II-20's model is more accurate than the state-of-the-art in interactive learning. The second experiment was a user study on a real use case inspired task, and the associated research question is essentially a sanity check. Is II-20 actually useful in solving a multimedia analytics task? Regarding the automated evaluation, we have observed precision and recall over time on three datasets. We have pitted II-20 against state-of-the-art baselines in interactive learning, both in relevance feedback and active learning configurations. And we have simulated Tetris and Grid separately. We can see that II-20 most of the time dominates the baselines on both precision and recall. And we can also see that Tetris does quite well compared to the Grid in many cases, which validates its analytic benefit. So to answer the associated research question, we believe that II-20's approach is certainly valid and improves the state of the art. Regarding the user study, the dataset we used was 8 hours of video, 8% of which was violent online political extremism content, or VOP for short. The dataset comes from a real use case, and it was designed in close collaboration with social scientists that conduct needles in the haystack tasks looking for propaganda among vast amounts of internet content. The task for our user study participants was to establish whether there actually is VOP content, and if so, what kind. None of the participants have seen the dataset before. There are actually 3 categories of VOP propaganda: Islamic terrorism, neo-Nazi, and Scottish ultranationalism. We had 11 users participating, and this is indeed a real task on a real data set. The observations from the user study were that all users were actually successful in finding VoIP content, so they were able to complete the task. To be fair, the response on Tetris was mixed or polarized. Some users strongly liked it, some disliked it, and some saw potential if Tetris would be adapted or if some features would be added. So there might be some future work coming up. The fast-forward interaction was deemed very useful by the users. Finally, a word on time complexity. We have averaged the interaction round times across all data sets. This data set is roughly 10K images, Celeba is roughly 200K images, and Places 205 is a large 2.5 million images data set. We are happy to report that all configurations of II-20 run in direct manipulation mode, which is under 2 to 3 seconds per interaction round. And in many cases, this time is slashed further into real-time mode, which is under 0.1 seconds. So II-20 is very suitable even on large-scale data sets. To conclude, II-20 is a complete multimedia analytics system for analytic categorization of image collections. We have introduced the first machine model to cover the entire exploration search axis without explicit feedback from the user. We have introduced a novel dynamic one image at a time metaphor in Tetris and a new semantic interaction in Fast Forward. And II-20 is fully interactive and responsive on even large data. Last but not least, II-20 is available under an open source license, so please feel free to download and use it. Thank you very much.